Hello, this is Math 2134 coming to you from the College page for the fall of 2020, and this is conclusion of the lecture entitled Pre-Calculus Review 2. When I left you last time, you were rationalize this denominator. I'll give you a little bit more time in case you didn't finish. You know what to do. Let's see how you did. Well, we're going to multiply top and bottom by 1 minus the square root of x over 1 minus the square root of x, which is of course equal to 1, and I will simplify and get this as my final answer. In other situations, it may be necessary to rationalize the numerator, that is, get rid of the radical in the numerator, and you do encounter this problem. So please rationalize this numerator. You know what to do. Let's see how you did. And here's what you will get. This time you're multiplying by 1 in this form. The square root of 1 plus h plus 1 over the square root of h plus 1. We simplify the numerator, canceling out the 1's and minus 1's. And then we cancel the h's, and this is our final answer. We now turn our attention to inequalities. Remember that we say that a is less than b if a is to the left on the number line of b. Now, inequalities work much the same way as equalities do, with one important exception. So we can add the same thing to both sides, and we can multiply by a positive number on both sides, and the inequality is maintained. But if we multiply or divide by a negative number, the sense of the inequality is reversed. And the solution of an inequality is often written in interval notation and often is many numbers, not just one. So here, let's find the set of real numbers that satisfy this inequality. You know what to do. Let's see how you did. So we're going to add 5 to all three places, here, here, and here, getting this. We're going to divide all the way by 2. The sense of the inequality remains undisturbed. And so the answer is the set of all x's that are bigger than or equal to 2 and less than 6. And this is how you write the answer in interval notation. Now here is solving a quadratic inequality. And notice it's important that we're comparing this to 0 because it's difficult to solve otherwise. You know what to do. Let's see how you do. Okay, so what we're doing is we're looking at the product of these two things, and so we factor it, and we say this is x plus 4, and this is x minus 2. Now that means the only place these things change signs are at minus 4 and 2. And so it's equal to 0 here, and it's equal to 0 here. And then I look at the sign of each factor. Now, what we're going to see is that the two factors have opposite signs only when x lies strictly between minus 4 and 2. Therefore, that's the solution, because we're saying when is this strictly less than 0. Here is an inequality that we want to solve, and this time it is bigger than or equal to 0. Again, notice we're comparing it to 0. You know what to do. Let's see how you did. So here, the zeros will happen at 1 and minus 1. So those are the places where it changes sign. And so now what I can do is I can look at what is the sign of the numerator and what is the sign of the denominator. And we see that they have the same sign whenever x is less than minus 1 or x is bigger than 1. And it's equal to 0 if x is equal to minus 1. Therefore, this is the solution. It's the union of these two intervals. This interval, notice the minus 1 is included, and this one, the 1 is not included because you can't have 0 in the denominator. Here is a word problem. Life is a word problem, and we'll do many word problems. So here, you should read this and pause this, give it a go, and we'll see how you do in a bit. Okay, a bit has passed. Let's see how you did. Well, you need to have this be bigger than or equal to 100,000. So what we do is divide both sides by 100,000, getting this. Then we add 1 to both sides and we get this. Then we square both sides, getting this, and then we solve for this. So x is bigger than or equal to 3,000. But we have to remember that x is measured in thousands of dollars. So this is $3 million. We also will study absolute values. This is the definition of an absolute value. The absolute value of a number is the distance the number is from 0. This is the formal definition. And so the absolute value of a is the distance from 0 to that point. And we have many properties of the absolute value. The absolute value of minus a is a. The absolute value of the product is the product of the absolute values. The absolute value of the quotient is the quotient of the absolute values. And very significantly, this is called the triangle inequality. The absolute value of a plus b is less than or equal to the absolute value of a plus the absolute value of b. This is very important, and we will use this in some of the proofs that we look at. So here is a problem 12 for you to do, applying the absolute values. You should realize that the absolute values take the role of parentheses also in the order of operation, in addition to potentially changing the number. So evaluate each of these expressions and evaluate them exactly. You know what to do. Let's see how you did. Well, here, since pi minus 5 is less than 0, then this absolute value is the negative of that. And so we're going to replace that this way, do the simplification, and we get 8 minus pi. That is the exact answer. And many things you'll be doing without a calculator, so the answer to this would be 8 minus pi. Here, since the square root of 3 minus 2 is less than 0, we get this. So when we substitute that in both places, here we get a negative and here we get a positive. We do the calculation and we get 2 times 2 minus the square root of 3. That is the exact answer. Here we're to solve the inequalities. When is the absolute value of x less than or equal to 5 and the absolute value of x greater than or equal to 5? You know what to do. Let's see how you did. So we see that whenever you have the absolute value of x being less than or equal to 5, you're between minus 5 and 5. And whenever the absolute value of x is bigger than or equal to 5, you are between minus infinity and minus 5, including that point, and 5 and plus infinity. So here's a problem for you to solve. When is the absolute value of 2x minus 3 less than or equal to 1? You know what to do. Let's see how you did. And so here what you're going to do is you're going to place 2x minus 3 in between minus 1 and 1, just like we talked about, and then you're going to solve it. Get x is between 1 and 2, and the endpoints are included, and this is the answer in interval notation. In closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now, more than ever, take care of yourself and of each other. God bless you all.